Hello YouTube, welcome to the garage. Over the weekend when I was at my other job, I've been doing some thinking, and with my ADHD kicking in, I wanted to know exactly how much bigger the half-inch line was from the quarter-inch line. And it's not just twice the size because it's a circle. So, and we all know from high school, to figure out the area of a circle, we have the area equals pi r squared. My math teacher, Mrs. Flynn, would be happy that I remembered that. Okay, so I did some calculations, and I'm just going to go over the calculations and kind of have a little discussion here. You know, maybe it might interest some people. You know, stuff like that kind of fascinates me, and I like to know the where and why. So we're just going to go over it, review a little bit of high school math, and then we'll go from there. So what I did is, you know, obviously I'm dealing with quarter and half-inch hose, and that's kind of small to see. I wanted to have a visual, so my scale is 4 inches equals 1/4 inch. So the 4-inch circle over there represents the 1/4 inch hose that's on there. The 4-inch, you know, excuse me, the 8-inch circle, it's twice the size of the other one, is directly proportional to the difference in size between the two hoses. Okay, so we have an 8-inch circle and a 4-inch circle. Again, the 8-inch is representing the half-inch hose. So we need to figure out the area. So a little bit of math here. Check me, make sure I get it right. I'm going to try and do this in my head. Okay, area equals pi. We're going to go with the 3.14. Times the radius, which is half of the diameter. So the radius on the 4-inch circle is 2 inches. 2 squared. Okay? So 2 squared, you know, is you multiply the 2 by itself. So 2 times 4, and 2 times 2 is 4. It'll be 3.14 times 4, which equals our area. So remove the decimal point times, oh, excuse me, yeah, I got it right, sorry, as the ADHD kicks in. 4 times 4 is 16, carry the 1, 4 times 1 is 4, add the 5, and then 3 times 4 is 12. Okay, so the area of that 4-inch circle is 1,256 square inches. Oh, no, I messed up, I forgot. Nice catch. I didn't put my decimal points back in there. I have 2 decimal places here. When I said that, I was like, man, I must have done some serious bad math, but please forgive me. I'm almost 64 years old. I've been out of high school a long time. So let me fix this here. So there we go. We got 2 decimal places. So the area of that is 12.56 square inches. Put that in here. 12.56. Okay, let's figure out the area of this one. So we got the, you know, area equals 3.14 times the 4 squared. Okay, so area equals 3.14, you know, 4 times 4 is 16. Okay, let's do some math over here and show our work. Again, Mrs. Flynn would be so proud of me. So, okay, so take our decimal points out so we can hopefully remember to put them back in next, you know, when we're done here. Okay, I'm going to do some multiplication here. So 6 times 4 is 24. Carry the 2. 6 and 1 is 6, plus 2 is 8. 3 and 6 is 18. 1 times 4, so we'll put our obligatory 0 there. 1 times 4 is 4, 1 times 1 is 1, and 1 times 3 is 3. Let's add this up. 4, 2, carry the 1, 9, 10, 5. Okay, this time we're not going to forget our decimal points, 2 of them. Okay, so the area of this circle is 50.24 square inches. All right, and yes, before anybody starts hammering away on the keyboard, you're right. This is not the area of that 1/4 inch hose, and this is not the area of the 1/2 inch hose. What I want to know is the relationship between them. How much larger is this one than that one? Okay, and the way we would do that, I'm going to cheat and use my calculator because I can multiply the division. So we want to see how much bigger this is than that. So okay, we're going to take 50.24 and divide it by the smaller number. 12.56 equals. The 1/2 inch hose is 4 times larger than that 1/4 inch hose. That's my point. And so I know what you're thinking. You're thinking if that 1/2 inch hose is 4 times larger than the 1/4 inch hose, and John, you got a 1 inch hose line right there. Why don't we go with the 1 inch? Because that would be 4 times more than the 1/2 inch. And you'd be right, but there's a such thing as the law of diminishing return, okay? You got to remember, we're up against the jet that's in the nozzle, in the gun. And again, you're right. I was complaining about the size of that nozzle, the jet in the gun. And it was, this is jetted, the gun that came with this is jetted for a 10 horsepower compressor. But if I made even a larger hose to this and could get all that that CFM to the gun, I'd run out of compressor. See, and that's kind of my point of this whole thing. This machine, the way it comes from the factory, is set up for a 10 horsepower compressor. And I had one of the gentlemen in the comments talking about that, the manufacturer stated what the CFM was to this machine, with the idea that you need to buy a compressor to match the machine. And especially a machine that's marketed towards the hobbyist, the DIYer. I'm just a one-man dog and pony show, okay? Compressors are expensive. The one I got, it's made by Eaton, their second line called Freight Train, but it's an Eaton compressor. So it's a 4-cylinder, 2-stage, 7.5 horsepower compressor, and I got it on sale. It was on sale for $1,800, and then I had to pay shipping from Ohio. I live in South Carolina now, and by the time I got it down here, paid shipping, it was right at about $2,500. And if I had, if I would have bought, and normally the compressor is $2,250, a actual Eaton 7.5 horsepower 4-cylinder 2-stage compressor is about $2,400, then shipping. So the discount I got buying it on sale almost covered the shipping, and then once you get it wired in, to support, it needed a 50 amp circuit to run that 7.5 horsepower compressor. So you're talking another $500. So I got $3 grand tied up in just getting the 7.5 horsepower compressor. If you want a 10 horsepower compressor, you're talking $4 grand easy, okay? And again, marketing this towards the hobbyist, it doesn't make sense to expect them to buy a compressor to fit the machine when it's so easy to reconfigure the machine to fit, a compressor, whatever you can afford, the size of the jet and the size of the nozzle. is what determines, what, if the compressor can keep up. And that's the idea. You want to get a balance between the compressor and the machine where you can run the machine continuously and the compressor can keep up. As you're running it, the compressor kicks on, pumps up, and then it can shut off. And you can keep blasting as long as you need to. That's my point. If you get the right setup between the compressor and the nozzle and the jet in the gun, it just works so much more efficiently, and you don't have to stop and wait for your compressor to catch up or anything like that, and you don't have to spend gobs of money buying a huge compressor when it wouldn't be practical if you're just a hobbyist. Now, as far as the gentleman, the keyboard warrior that was faulting me with my logic, again, I kind of wanted to, that's one of the reasons I wanted to go through all this, was faulting me in my logic. And according to him, I mentioned engineering, and according to him, since Vapor Honing Technologies is an international company, that they surely would have done engineering, and that the way this is engineered would be the optimum performance. Well, that's a fallacious argument. An appeal to authority, to be exact. Just because they're an international company does not mean they have good engineering. Sorry, they're not, it just doesn't work that way. The only thing I would say, as far as if they wanted to stick with the 1/4 inch hose on this, run it 1/4 inch all the way to the gun. Because when you go from a 1/4 to a 1/2, you're losing pressure and velocity right before you get to the gun, and that's not exactly, in my opinion, the right way to go about it. So as far as this is concerned, that's kind of what I wanted to point out. What I'm going to do next is, again, like I've said before, I want to kind of see what the difference is. What I'm going to do is I'm going to charge the compressor up to 150 psi, have the regulator set at 60, and I'm going to step on the treadle with the gun disconnected, just the air hose, and see how fast it goes from 150 to 90 psi at 60. Then I'm going to crank the regulator up to 80, go from 150 to 90, and see how fast it does that. And then I'm actually going to disconnect this 1/4 inch hose, and I'm going to hook it directly to this 1/2 inch hose with no regulator in it, just the valve, the 1/4 inch, and this way it's set up, and it's going to be straight from, like I said, this 1/2 inch to the hose inside. And my logic is, the faster you try to put, the faster the throughput of the air, the more profound the difference between the 1/4 inch and the 1/2 inch will be. That's my theory. And so I'm going to test that. And then once I change it out, I'm going to do the same thing. 60 psi, 150 to 90, 80 psi, 150 to 90, and straight, just straight 1/2 inch from here all the way to the hose inside, and see how fast it'll blow the compressor down from 150 to 90. So according to this math, I would think there would be a considerable difference. But again, I want to prove it. So that's what I'm going to do next. I am going to do this testing and get this all changed out, and I'll share with you my findings. So make sure you like and subscribe. It would really help out the channel, and I'd appreciate it more than you'd ever know. So I will see you in the next video. So much for math on Monday, right?